Alright, so back with another little video here. These are the questions from the Congruent Triangles chapter. I'm going to guess 6B, but I can't really remember, to be honest, what the letter is. You can check it up. But you know if you need help with congruent triangles. This is the question. These are the questions for the enrichment section. A circle with a centre O has a chord AB. M is the midpoint of the chord AB. Prove OM is perpendicular at right angles to AB. That's our first one. I'll get a nice fine pen. That should be big enough to still show up nicely. So I've got question A over here. I've drawn in, put in my centre of my circle. O has a chord AB. M is the midpoint, so it divides the chord into two. Prove that OM, so this line here, is perpendicular to AB. Now, what we want to do here is we want to try and establish some congruence. So what I'm going to do is draw a radius. It's always a good idea whenever you've got a circle question to draw radii in where you think they may be useful. So you can see I've got two triangles now. I've got triangle OAM and another triangle OBM. I guess I've got triangle OAB as well. But I'm interested in the two smaller triangles. What I'm going to try to do here is show that they are congruent. So let's have a look. First of all, I can say OA is congruent to OB, or is equal to OB is fine. Why are they equal? Well, they're both radii. So that works nicely. They must be the same length. I also know AM is equal in distance to BM, because we were told M was the midpoint. So you can just say that information was given in the question. And then I've got OM is a common side to both triangles. Note when I'm writing the order of the things, OAM and OBM, I'm keeping the corresponding vertices the same. So OAM from the top to the very acute angle to the one where we think the right angle might be, and OBM from the top to the very acute angle to the one where we think the right angle might be. Keeping the corresponding angles in order makes everyone's life a lot easier. So I've got that there. What do I have now? Well, I can conclude if the radii are equal, the adjacent sides are the bases are equal because M was the midpoint, and then there's a common side. I could conclude triangle OAM is congruent to triangle OBM. Knowing that, I now know, I'm going to see if I can just insert some space here. Oh, look, that did work nicely. I still have to be very careful to spell out exactly what I mean here to prove that the angles are going to be 90 degrees so that OM is at right angles to AB. But I'm on my way. Because these triangles are congruent, I can now say angle AMO equals angle BMO. This angle here and this angle here must be equal as they are corresponding angles in congruent figures. Also, angle AMO plus angle BMO add up to 180 degrees. They are supplementary because AB is a straight line. Therefore, if those two angles are equal and they both add up to 180 degrees, angle AMO equals angle BMO, which is 90 degrees. Now I can write my conclusion. Therefore, OM is perpendicular to AB, which is what they wanted us to write. And we finished that one. Question B, you can see I've got the diagram here already for us. What was the question? Two overlapping circles with centres O and C. Right, there's O, there's C, that's fine. Intersect at A and B. I'm going to put A at the top, B at the bottom. Prove that angle AOC is equal to angle BOC. Okay, well I'm going to have to put the line in between them there. And I've got to show that this angle in here, AOC, is equal to this angle BOC. If I can show their corresponding sides in a right angled triangle, I should be fine. What can I label here again? Well, I've got a radius. Actually, this is the bigger circle, so I'll give that the big R for the radius. And then I've got the little circle, so that's a little r for the radius. And then you can see the top triangle and the reflected upside down triangle both share side OC. So we can go ahead and write out our same argument as before. And this time, I'm going to let the diagram speak for itself, and I can say, oh no, I will write it out. So first of all, I've got OA equals OB. Those distances are equal because they're radii of the same circle. AC equals BC. They're also radii of the same circle as each other, not as the first two. And then I have OC is common to triangle OAC and triangle OBC. Therefore, triangle OAC is congruent to triangle OBC from our rule side, side, side. Oh, I didn't write side, side, side after in the previous one. I probably should have done that. Hopefully I said it. I'm sure I would have. All right, so if they're congruent figures, therefore, since angle AOC and angle BOC are corresponding angles, in congruent triangles, we can conclude angle OAC equals angle OBC. All right, back with the last question. Just had an interruption there, but it's all good. You won't have noticed. Triangle ABC is isosceles. So I've got triangle ABC. I've labelled the isosceles sides, noting that AC and BC were the equal length. So I just made sure I indicated those vertices correctly. D is a point on AC. So D is a point on AC such that angle ABD and angle CBD are equal. So I'm just going to indicate that by putting a little dot in each of those. They're equal. That'll do. Next I have point E on side BC such that BAE and CAE are equal. So I'm going to give them a different symbol. I'll use little alpha there. Those two side angles are equal. Okay, they've now asked me to prove that AE and BD intersect at F. AE and BD intersect at F. Okay, that's the point where they intersect. And I want to show that AF is equal to BF. And somehow I have to go about that. Well, if AF equals BF, I'm thinking in my head, I'm going to need to show that this is an isosceles triangle. So what I would like to show there is that angle alpha equals the angle with the dot in it. So can I go ahead and prove that? Let's have a go. Since a triangle ABC is isosceles, and I'm given that angle CAB is equal to angle CBE, A, because we were told the side lengths AC was equal to BC. So I can conclude that since it is isosceles, I know that CAB and CBA are equal as the angles opposite the equal sides. Therefore, 2 times angle alpha, which is what forms all of the angle A, must be equal to 2 times whatever angle I made with the dot in it. Well, dividing each side by 2, I've got angle alpha equals the angle with the dot in it. So therefore, well, I've shown those angles are equal. Therefore, the opposite sides will also be equal. AF is equal to BF, which is what they wanted me to show. So I've gone ahead and finished that one. Good work. Those ones are a little bit tricky. You've got to read carefully. You've got to just take your time with making sure you get labels in the right place. But once you've done that, I think you'll find they're not too bad. Hopefully that helps whoever looks at this. Good luck and keep up the good work, people. Cheers.